So what's all the fuss about? What do we need phasor diagrams for? Remember first the expression that's relating the voltage across the generator to the voltages across the resistor, capacitor, and an inductor for a series RLC circuit. That expression that we have here. Now, remember also the phasor diagram is going to have VL max, the VR max vector, and the VC max vector. And these are going to be rotating counterclockwise as time progresses. Remember also that at any instant we can get this, the voltage across the generator, or the voltage across each of the elements by looking at the y component of the vectors. We can look at the y component of VL, VC, and VR. Now, once we get these, we can use these to find Vgen. Now, in general, can we use that to be able to figure out Vmax across the generator, for example? Can we use that to figure out if the generator is ahead or lags behind the current? Obviously, yes. So how do we do that? We examine our diagram and we note that VL max, the vector for VL, and VC are in opposite directions. So essentially what we are doing, we are thinking of these as vectors. And we are going to add them up as vectors. So we have VL max pointing up, VC max pointing down. So we add them up to find this vector here. VR max is alone. So my overall vector is going to be the sum of VL max minus VC max and VR max. Since they are vectors, the way we get the sum, and this is easy since they are perpendicular, as the diagonal of my rectangle. The phase angle is going to be the angle that Vmax gen is going to make with the x-axis. And from that angle, we'll figure out if it is ahead or lagging. If it is positive, it's ahead. If it is negative, it is lagging. So it's as simple as that. Now, if we look at this a little bit further, we can remember that each of the maximum values is related to Imax with an expression similar to this. VC max is XC Imax, VL max is XL Imax, VR max is R Imax, and of course Vmax generator is Imax C. Now, since all of them have Imax in them, this is really what we have. One might wonder, can we simplify all of these by Imax and just draw XL, XC, R, and Z? Would we get similar information? Of course we can. And that's the way it's going to look. So now we have the phasor diagram for impedances. So we have the reactance or the impedance across the inductor, the reactance or the impedance across the capacitor, the reactance or the impedance or the resistance of the resistor, and we do the same phasor diagram. Now, how would I get then Z? Look at that expression that we had before. It comes exactly from here. One side of the rectangle is R, one side XL minus XC, so it's square root of R squared plus XL minus XC squared. So what's the phase angle? It's just the inverse tangent of the opposite over the adjacent, the inverse tangent of XL minus XC over R. That's the way we get that.